Good day, everyone. My name is Matthew Acedera from University of Rizal System Morong Campus, and here's my requirement for route surveying CE3. For today's video, we will talk about highway and railroad curves. There are 5 highway and railroad curves, namely the simple curve, the compound curve, the reverse curve, the spiral curve, and the parabolic curve. But before we start, let me just tell you the elements of curves. PC for the point of curvature, PT for the point of tangency, PI for point of intersection, R is the radius of the curve, D for degree of the curve, T for tangent distance, I for angle of intersection, E for external distance, M for middle ordinate, LC for length of curve, C for long chord, C1 and C2 for subchords, D1 and D2 for subangles. Simple curve. In the first problem in simple curve using metric arc basis. First, a simple curve has a radius of 286.48 meters. Its distance from PC to PT along the curve is equal to 240 meters. So along PC to PT, this was 400 or 240 meters, and the radius was 286.48. Before we get the I, or the center angle of the curve, we must get first the degree of the curve. Using the formula, d is equal to 1145.916 over r, the radius. So substitute the given values, so d is equal to 4 degrees. Using the formula, LC over I is equal to 20 divided by d, or the degree of the curve. Substitute the given values, I is equal to 48 degrees. Letter B, the distance from midpoint of the curve to the midpoint of the long chord. Using the formula, m is equal to radius of the curve times 1 minus cosine I over 2. Given the formula, substitute the values. R, 286.48 times 1 minus cosine 24, 42, the I divided by 2 is, or rather 48 divided by 2 is 24. M is equal to 24.76 meters. Next is letter C, the area bounded by the tangents and outside the central curve. Before we get the area, we must get first the tangent, which gives the formula T is equal to R tangent 24. Substitute the radius of the curve, then we will get T is equal to 127.55 meters. Then, we will find the area using the formula TR times 2 divided by 2 minus pi r squared times I divided by 360. Given the formula and given the values, substitute the values in this formula. So we will get area is equal to 1,162.8 meters squared. Using metric chord basis. Same as the given earlier, but in this problem, we will use another formula to get our central angle. But first, we will find our degree of the curve using the formula. Sine d over 2 is equal to 10 divided by r, 286.48. Use cross method equals t is equal to arc sine 10 times 200 divided by 286.48 times 2. Then we will get d is equal to 4 degree. So using the formula earlier, LC over I is equal to 20 divided by 4. So I is equal to 48 degrees. Letter B, distance from midpoint of the curve to the midpoint of the long chord. Using the formula of midpoint is equal to R times 1 minus cosine I over 2. Substitute the given values. We will get 24 by dividing 48 divided by 2 is equals to, our m is equals to 24.76 meters. Letter C, the area bounded by the tangents and outside central curve. Before we get the area of the bounded tangents and the outside central curve, we must get the tangent first. By using the formula T is equal to R tangent 24 degrees, and by giving the values of R, which is 286.48, we will get T is equal to 127.55 meters. And to get the area of the tangents, we must use the formula TR times 2 divided by 2 minus pi R squared times I divided by 360 degrees. So, given the values of the formula and the formula rather, we must get the area is equals to 2162.8 meters squared. In using the English arc basis, so here is the second example. A simple curve has a radius of 939.895 feet. Its distance from PC to PT along the curve is equal to 787.402 feet. So this was the distance from PC to PT, our midpoint, our angle 48 degrees, and our radius 939.895, and this was the half of our angle. So in finding the central angle of the curve, we must first find the degree of the curve using the formula 5729.58 divided by the radius. The given radius is 939.895. Given the values, we must substitute it, and the answer for the degree of the curve is 6.09 degrees. So using this formula, we will get the central angle of the curve, which is the 48 degrees. Let there be the distance from midpoint of the curve to the midpoint of the long chord. Using the formula m is equal to r times 1 minus cosine I over 2, substitute the given values of r and I. The central angle 48 degrees divided by 2 is 24, so we will get m is equal to 81.258 feet. Next is the area bounded by the tangents and the outside the central curve. So we must get first our tangent before we get the area. So using the formula T is equal to R tangent 24, substitute the radius of the curve, then we will get T is equal to 418.468 feet. Using the formula of area, T times R times 2 divided by 2 minus pi R squared times I divided by 360, we will get the substitute values of area. Then we will get the area of 23277.160 feet squared. Next is the English chord basis, same as the given earlier, but in this problem, we have the different kind of method in using this in computing this degree of the curve rather. In finding the degree of the curve, we must use the formula sine d minus 2 is equal to 50 divided by the radius of the curve. So given the radius of the curve 939.895, so we must use the cross method and substituting all the values. So we must get the d is equal to 6.098 degrees. So using the formula earlier, that LC divided by I is equal to 100 divided by our d. So we must get I is equal to 48 degrees. Next is B for distance from midpoint of the curve to the midpoint of the long chord. We must use the formula of m is equal to r times 1 minus cosine I over 2. Substitute the given values. 48 divided by 2 is 24. Then we will get m is equal to 81.258 feet. Next is the area bounded by the tangents and the outside central curve. So before we get our area, we must get first our tangent using the formula T is equal to R tangent 24. Substituting the value of our radius of the curve 939.895, we will get their T is equal to 418.468 feet. So we must get now the area using the formula TR times 2 divided by 2 minus pi r squared times I divided by 360. Substituting all the values given, so we have the area is equal to 23277.160 feet squared. Compound curve. Using metric arc basis, here's our given number 2, or number 1 rather. Given a compound curve, I1 is equal to 24 degrees, I2 is equal to 36 degrees, D1 is equal to 6 degrees, and D2 for the 4 or D2 is equal to 4 degrees. Compute the length of the common length of the compound curve. Use arc pieces. Compute the PC if PI is at station 12 plus 988.20 and compute the station of PT. So first is the length of the common tangent of the compound curve. So here's our figure. Here's P to PD, R1, and this is our T1 and T2. This is our angles 26 and 36 degrees, our 24 and 36 degrees. Then here's our degree of the curves, D1 and D2. So before we get the length of the common tangent, AB, we will get first our radius of the curve, the first radius of the curve and the second radius of the curve. Using the formula, 1145.916 divided by 6, the first degree of the curve, is equal to 190.99. This next is R2 is equal to 1145.916 divided by the second degree, 4, is equals to 286.48. Using the formula for the length, is AB is equal to R1 tangent I1 divided by 2 plus R2 tangent I2 divided by 2. So using the given values, we have AB is equal to 133.68 meters. Next is the station of PC if the point of intersection is at station 12 plus 988.20. So before we get our station of the point of curvature, we must get first our D. Using the formula D divided by sine 36, our I is equal to 133.68 divided by sine 120. So we will get our D is equal to 90.73. After getting our D, we should get our the station of PC of curvature is equals to 12 plus 988.20, this one, our PI, minus our D, 90.73 plus 60. And there we go. Our final answer for the station of the point of curvature is equal to 12 plus 837.47. Next is compute the station of the point of tangent C. PT is equals to our PZ plus 190.99 times 24 times pi divided by 180 plus 286.48 times 36 times pi divided by 180. Then we will get our PT is equals to 13 plus 097.4724. Next is using our metric chord basis. So same as the given earlier, but in this problem we must use these formulas to get our first and second radius of the curve. First, we must use the second degree of the curve. Sine d2 divided by 2 equals 10 over r2. So substitute the given values. So we will get r2 is equal to 286.537. Next is the first degree of the curve. Using this formula, we will get R1 is equal to 191.07. Using the formula in the common length of tangent is AB is equal to R1 tangent I1 over 2 plus R2 tangent I1 or I2 over 2, sorry. So, and then we will get the value of AB is equal to 133.71 meters. Next is the station of PC if the point of intersection is at station 12 plus 988.20. Before we get our PC, we should get first our D. So using the formula, D divided by sine 36 or equals 133.71 divided by our sine 120 is equals to D 90.75. Then we will get our station of PC 12 plus 988.20 minus RD plus 60 is equals to 12 plus 837.45. Next is compute the station of the point of tangency using the formula PC plus 190.99 times 24 times pi divided by 180 plus 286.48 times 36 times pi divided by 180. Here we go. We get PT is equals to 13.097.45. Next is using English arc basis. So same given as earlier in this compound curves, but using the point of intersection is 68577 plus 96. So at first, we should get the length of common tangent of the compound curve. Using the formula in the arc basis English unit, 5729.58 divided by 6 degrees, our first degree of the curve, is equals to 954.93. Then the second radius of the curve is 1432.395. Using the formula, AB is equal to R1 tangent I1 divided by 2 plus R2 tangent I2 divided by 2. Here we get the AB is equal to 668.389 feet. Next is the station of the PC if the point of intersection is at station 685776 plus 96.000. So before we will get our PC, we must get first RD. So the formula D divided by sine 36 is equal to 668.389 divided by sine 120 is equals to 453.646. Then we will get our PC from 685776 plus 96 minus our D plus 196.85. Then we get our PC 685770 plus 45.15. Next is for the computation of the point of tangent C. PT is equal to our PC plus 954 plus 93 or 0.93 times 24 times pi divided by 180 plus 1432.395 times 36 times pi divided by 180. Then we will get our PT 685783 plus 45.50. Next is the English chord basis. Given the compound curve of the same given as earlier, but the difference is we will use the different formulas in getting the radius of the curve. Using this formula, sine d over 2 is equal to 50 divided by r1. So given the values, so rd is 6 divided by 2 is 3. Then here at 4 divided 2 is 2. So we will get r1 is equal to 955.36 and r2 is equal to 1432.658. Using the formula to get the length of the common tangent, AB is equal to R1 tangent 1, RI 1 divide 2 plus R2 tangent I2 divide 2. So substitute the given values, we will get AB is equal to 668.566 feet. Next is the station of PC if PI is at station 685576 plus 96.000. Before we get our PC, we must get first our D using the formula. D is over sine 36 degrees equals 668.566 divided by sine 120. So here we get D is equal to 453.766. Then we will get our station of PC 685776 plus 96 minus D plus 196.85, then we will get our PC 685770 plus 45.38. Next is the point of tangent C is equals to our PC plus 955.36 times 24 times pi divided by 180 plus 1432.658 times 36 times pi divided by 180. Then we will get our PT 685783 plus 45.73. Reverse curve. Using the metric arc basis, here's our example number 1. A reverse curve connects two converging tangents intersecting at an angle of 30. The distance of this intersection from P of the curve is 150 meters. The deflection angle of the common tangent from the back tangent is 20, and the azimuth of the common tangent is 320 degrees. The degree of the curve of the second simple curve is 6 degrees. And the stationing of the point at the intersection of the first curve is 4 plus 450. So determine the radius of the first curve, determine the stationing of PC, and determining the stationing of PD. So here's our I, our angle, or the intersecting angle of tangents. Here's our P, our 150 meters, and here's our point of intersection. Then this was the figure of in problem number 1. By getting the radius of the curve, we must first get the length of the common tangent AB. By using the formula AB divided by sine 30 divided or equals 150 divided by sine 20. So cross method, we will get AB is equal to 219.29 meters. By getting the I or the intersection or the central angle rather, is we will first use our T1 plus T2 equals to our AB. So with that, I2 is equal to I1 plus 30 degrees. 50 is from 30 plus 20 is equals to I1 plus 30 is equals, or I1 is equals to 20 degrees. By using this formula, we will get our R2 or the second radius of the curve. R1 tangent I1 divided 2 plus R2 tangent I2 divided 2 is equal to our AB. So using this formula, 1145.916 divided by RD2, our degree of the curve is equals to 6. Our R2 is equal to 190.99 meters. Then we will get our first radius of the curve using this formula. R1 tangent 10 degrees plus 190.99 R2 tangent 25 is equal to our AB. Then we will get the first radius of the curve is 738.68 meters. Next is the stationing of PRC. Before we get our stationing of PRC, we must get first our degree of the curve, the tangent, the station of PC, and our length. So first, we must get our first degree of the curve using the formula 1145.916 divided by the given R1 earlier. So we must get D1 is equal to 1.55 degrees. To get the first tangent is by using the formula R1 tangent I1 divided by 2. So we will get the given R1 tangent 10, 20 divided 2 is equal to 10. Then we will get T1 is equal to 130.25 meters. Next is we will get the station of PC, or the point of curvature, is equal to the given point of intersection 4 plus 450 minus 130.25 our T1. Then our station of PC is equal to 4 plus 319.75. Next is we will get our L1 is equals to 20I1 divided by D1. Substituting the values is equal to 258.36 meters. Next is our station of PRC. So we must add the station of PC plus our L1. By getting that, we must get our PRC is equals to 4 plus 577.81. Next is the stationing of our point of tangent C. Using the formula of getting L2 is equal to 20I2 divided 2, substituting the formula or the given values, L2 is equal to 166.67 meters. By getting the station of the point of curvature or tangent C rather is equals to 4 plus 577.81, our station of PRC, plus 166.67 is equal to 4 plus 744.48. Next is the metric chord basis. So same given as earlier, but in this problem, we will use another method. So by getting the first radius of the curve, we must get first the common length or the common tangent, our central angle, and our second radius of the curve. So first, our length of the tangent, common tangent. AB is equals to 200.19.29 meters. Using this formula, AB divided by sine 30 degrees is equal to 150 divided by sine 20. By getting that, we must use, we will find next is our central angle using the formula IT is equal to I1 plus 30 degrees. This 50 degrees degrees came from 30 plus 20. This is equals to I1 is plus 30. I1 is equal to 20 degrees. Next is we will get our second radius of the curve by using the formula of sine d2 divided 2 is equal to 10 divided by our r2. So 6 divided 2 is 3. Then we will get our r2 is equal to 191.07 meters. Then we will get our r1 by using the formula r1 tangent 10 degrees plus 191.07 our r2 tangent 25 degrees is equals to our AB. So substituting all the values, we must get our first radius of the curve 738.47 meters. Stationing of PRC. Before we get our stationing of PRC, we must get first our degree of the curve, tangent, station of the point of curvature, L1, and lastly with our PRC. So we must get first our degree of the curve. By using the formula, sine d1 over 2 is equals to 10 divided by r1. So earlier, we have the value of r1 is 738.47. Substituting the value and using the cross method, we will get our first degree of the curve is 1.55 degrees. Next is we will get our tangent. By using the formula r1 tangent I1 divided by 2, then substituting the values of r, then I1 20 divided 2 is 10. So we will get T1 is equal to 130.21 meters. Next is station of our point of curvature. Given our PI or the point of intersection 4 plus 450 minus our T1 130.21. So we have the PC 4 plus 319.79. So here in L1, we must use the formula 20 I1 divided by D1. So here's our D1, so we will get 258.06 meters for our L1. Last but not the least, our station of PRC is equals to our station point of curvature plus our L1. So we have 4 plus 577.85. Next, our stationing of point of tangency. We must first get our L2 by using the formula 20I2 divided by 2. Substitute the values. We must get L2 is equals to 166.67 meters. To get our station of point of tangency is equals to our station of PRC plus 166.67 station is equals to our L2 is equals to 4 plus 744.52. Next is by using English arc basis. Here's our given example. A reverse curve connects two converging tangents intersecting at an angle of 30. The distance of this intersection from P of the curve is 490.126 feet. The deflection angle of the common tangent from the back tangent is 20 r and the azimuth of the common tangent is 320 degrees. The degree of the curve of the second simple curve is 6 degrees and the stationing of the point of intersection of the first curve is 145 plus 99.74. Here's our given figure, and we must get the first radius of the curve, stationing of PC, and stationing of B. First, we must get the radius of the curve by using all these formulas. In computations, AB is divided by sine 30 is equals to 490.126 divided by sine 20. Use cross method. Our AB is equal to 719.44 feet. Next is we will get our central angle. So I2 is equal to I1 plus 30. So 50, 30 plus 20 is equals to I1 plus 30. So I1R is equals to R is equal to 20. Next is we will get our R2. By using the formula 5729.578 divided by RD2. So we will get our R2 954.929 feet. So to get our first radius of the curve, we must use the formula R1 tangent 10 degrees plus 954.929 or R2 tangent 25 is equal to 9719.44. So by using all the computations here and formulas, R1 is equal to 1549.745 feet. Next is the stationing of PRC. Before we get stationing of PRC, we must get the first degree of the curve, tangent, PC, L1, and then the PRC. Next, or the first thing first, we must get the degree of the curve using the formula 5729.578 divided by r given or the r computed radius of the curve 1549.745. Given that we have T1 is equal to 3.69 degrees. Next is we will get our T1 is equal to R1 tangent I1 divided by 2. Using that formula, substitute all the values. I1 is 20 divided by 2 is 10. So we must get T1 is equals to 273.260 feet. Next is the station of EC. So we must add or subtract rather the T1 or the PI to our T1. Then we will get our PC1143 plus 26.48. Next is our L1. Using the formula, 20 I1 divided by T1 is equal to 108.48. Last but not the least, our station of PRC is by adding station of PC plus our L1. So we will get 144 plus 34.88. Next is our stationing of we must first get our L2 by using the formula 20I2 divided by D2. So given the values, we must get L2 is equal to 166.67. Then we must add to get our PT, add our station at PRC plus our L2. So we will get 1146 plus 01.55. Spiral curve. Metric arc basis. So the first given is the two tangents having azimuths of 250 degrees and 292 degrees are considered by a 90-meter spiral curve with an 8 circular curve. The width of the roadway is 15 meters. If the design velocity is 70 mph, so we must determine the super elevation at quarter points, deflection angle at the end point, and the external distance. So here's our given figure. So we must first get our super elevation quarter points. And on getting our super elevation quarter points, we must first get our radius of the curve. By using the formula 1145.916 divided by our degree, which is 8, then we will have 143.239 meters. This one. Then next is we will get our E using the formula 0.0079 k squared divided by r. By using that, we must get r e is equal to 0.270 meters width of roadway. So in this problem, we must get at quarter point. So quarter means 4, right? So next is we will get our E4 4.05, E1 1.012, E2 is 2.025, and E3 is 3.037. Next is by getting the deflection angle at the endpoint. So given this figure, we should get our S first. Using the formula is equals to S equals to LC divided by 2RC 180 divided by 5. Using cross method, S is equal to 18 degrees. Then I, or the deflection angle of at the endpoint, is equals to S divided 3. 18 divided 3 is 6. Next is our external distance. ES, or external distance, is equal to RC plus XE divided 4 second I over 2 minus RC. So here's our general formula, but before we get our external distance, we must guess, or we must first answer the I. So given the substitute values, given all the values, we must substitute it and we will get I is equal to 42 degrees. So next is we will find XC by using the formula S or LC squared divided by 6RC. So given the values, we must get XC is equal to 9.42. So by using this general formula, we must get ES is equal to 12.71 meters. Next is by using metric chord basis, same given as earlier, but on this problem, we have different way of solving our radius of the curve. Using the formula, r is equal to 10 divided by sine, the degree of the curve divided by 2. So our degree of the curve is 6, so 6 divided 2 is 3. So we have r is equal to 143.35 meters. Next is we will get our e by using the formula 0.0079 k squared divided by r, by substituting the given values, we must get E is equal to 0.2 centimeters with off-road E. By getting the super elevation quarter points means 4, E4 is equals to 4.05, E1 is equal to 1.012, E2 is equal to 2.025, and E3 is equal to 3.037. Next is the deflection angle of the endpoint. So given the figure, so we must get first our S using the formula LC divided 2RC times 180 divided by pi. Use cross method, we then substitute all the values, then we will get S is equal to 80 degrees, then I, the formula for deflection of the angle is equal to S over 3, 18 divided 3 is 6. Next is external distance. So for our external distance, we must first get our I and XE. So by getting I, substitute all the values, 292 divide or minus 250 is equal to 42 degrees. So by getting XE, use the formula LC squared divided by 6RC. Substitute all the values, then we will get XC is equal to 949.417. So using this general formula for external distance, we will get our ES is equals to 12.72 meters. Next is by using English arc basis. So in this problem, we have two tangents having azimuths of 250 degrees and 292 are connected by an 295.276 feet spiral curve with an 8 circular curve. The width of the roadway is 49.2126 feet. If the design velocity is 102,667 feet per second, determine the super elevation, the deflection of the angle, and external distance. So here's our given figure. And we must first get the super elevation of quarter points using the formula in English unit arc basis. 5729.58 divided D. So our D is 8. Then we will have 716.197 feet. Using the formula, E is equal to 1.46 k squared is divided by our radius of the curve. So substitute the value 102.667 is came from our design velocity. So we will get E is equal to 31.37 feet width of roadway. So in getting the elevation of quarter points means 4 is equals to E4 is equal to 1543.799. E1 is 385949 and E2 is 771899 and E3 is 1157849. By getting the deflection of the angle of at the endpoint, we must first get our S before we will find our deflection angle. First, we must use the formula for S is equals to LC divided by 2RC times 180 divided by pi. So substitute all the values and we will have S is equal to 12. 12 divided 3 is 4. Next is our external distance. So we must use the general formula of ES is equal to RC plus XC divided by 4. Second I over 2 E minus RC. So we must get first our circle angle is equals to 292 minus 250. Then we will have our angle 42 degrees. Then next is we will have XC or equals to LC squared divided by 6RC given the values. Substitute all the values and we will get XC is equal to 20.289. By using this general formula for external distance, substitute all the values. Here's our XC, here's our R, and here's our angle 21 because 42 divided 2 is 21. So then we will get 56.3868 feet. Tama ba? Yes. Next is by using English chord basis. Same as the given earlier, but in this problem, you must use for R is equals to 50 divided by sine degree of the curve divided by 2. The degree of our curve is 8 divided by 2 is 4. So R is equals to 716.779. Then by computing or finding the super elevation of quarter points or the super elevation, given the formula is equals to 1.46 times k squared divided by r radius of the curve. Here's our the design of velocity 102.667. So squared mo lang. Then just substitute all the values. Then we will get E is equal to 31.34 feet per second width of roadway. So in this problem, we must find quarter points. E4 is equals to 1542.322. Then E1 385.580. And E2 is 771.161. And E3 is equal to 1156.74. Next is the deflection angle of the angle point, or at the end point, sorry. But before we get that, we must get first our S. By using the formula LC divided by 2RC times 180 divided by pi, cross method, then we will get S is equal to 12. 12 divided 3 is 4. Next is our external distance. Using the general formula, external distance is equal to RC plus XC divided by 4 second I over 2 minus RC. So we must first get RI, horizontal angle, 292 minus 250 is equal to 42 degrees. Next is our XC using the formula LC squared divided by 6RC. Substitute all the values, then we will get XC is equal to 20.273. Using the general formula, substitute all the values. Here's our XC, here's our RC, and here's our I, 42 divided by 2 is 21. So then we will get our external distance is 56.424 feet. Next, and but not the least, is our parabolic curve. In using metric symmetric, here's our problem. A symmetrical parabolic summit curve connects two grades of positive 6% and 4%. It is to pass through a point P, the stationing of which 35 plus 280 and the elevation is 198.13 meters. If the elevation of the grade intersection is 200 meters, with stationing 35 plus 300. Determine the length of the curve, stationing of elevation, and elevation of PC, stationing and elevation of P. Here's our given figure. So here's our the elevation of great intersection, 35 plus 300. Ito yung stationing niya. Here's our L1, PC. And here's our elevation, sorry, 200 meters, G1. And yeah, to determine the length of the curve, here's our figure again, and we must first get our P, Y, H, and lastly our L. We must first get our P is equals to 200 minus 20 times 0.06 is equals to 198.80. So by getting our R1, our Y, sorry, you must use the formula P minus 190.30. So Y is equal to 0.67. Here we will get our H by using the formula H is equal to 1 over 4 G1 minus G2 L over 2. So H is equal to 0.10 L, 0.06 plus 0.04 L divided by 8. So we will get H is equal to 0.0125 L. By using the formula L divided 2 minus 20 squared divided by Y is equals to L divided 2 squared divided by H, we will get our substitute values. Then we will get our L squared divided 4 minus 20L plus 400 equals to 13.4 L. So we will get our L is equals to 240 divided 2. L is equal to 120 meters. Next is our stationing and elevation of EC. So we will get the stationing of the point of curvature by adding our P1 minus 60. Then we will get PC is equal to 35 plus 220. Then next is our elevation of PC, 200 meters minus 60 times 0.06. Then we will get 196.4. Next is the stationing and elevation of PT. And in the first station of PT, we'll must add the 35 plus 300 RPI plus 60 is equals to 35 plus 360. Then in the elevation of PT, 200 meters minus 60 times 0.04 RG2. So we have the elevation of PT 197.6. Next is by using English symmetric. Here's our example. A symmetrical parabolic summit curve connects two grades plus of positive 6% and 4%. It is to pass through a point of P stationing of which 1157 plus 48.031 and the elevation of 633.628 feet. If the elevation of the grade intersection is 656.168 feet with stationing of 1158 plus 1365. So here's our given figure. And we must get the length of the curve, stationing of the elevation of PC, stationing elevation of P. So here's our P, stationing of P. Then here's our G1 and G2. And yeah, to determine the length of the curve, we must first get the P, Y, H, and our L. So here's the given figure. We must first get our P is equal to 656.168 minus 65.61 times 0.06. Our G1 is equals to 652.213. Then P to get Y, P minus 633.628 is equals to 18.585. Using the formula H is equal to 1 over 4 G1 minus G2 L divided by 2, we will get our H is equal to L divided 8 times 0.06 G1 plus 0.04 G2. So we have H is equals to 0.10 L divided by 8, which gives us H is equals to 0.0125 L. Next is for the length of the curve. L divided 2 is minus 65.61 squared divided by y is equals to L over 2 squared divided by RH. Substitute the given values here, then we will get L divided 2 is minus 65.61 squared is equal to 371.70 L. Then we have L squared divided 4 minus 65.61 L plus 404.67 plus 371.70 L. Then we will have our L is equal to 1746.775 feet. Next is for our stationing and elevation of PC. So to get our station of PC, we will subtract the 1157 plus 48.031, this one, minus 65.6168. So we will get our station of PC of 1156 plus 82.41. Next is the elevation of PC. We must subtract 656.1682 65.61 times 0.06, and we will get the elevation of PC 652.23. And next is the station and elevation of PT. So we must first get the PT 1158 plus 13.65 plus 196.85 is equals to 1160 plus 10.50. Next is the elevation of PT, which gives us 656.168 minus 196.85 is which gives us the value of elevation of PT is equals to 648.294. Next is by using metric unsymmetrical. So here's our given. A negative 3% grade meets a positive 5% grade near an underpass in order to maintain the minimum clearance allowed under the bridge and at the same time introduce a vertical transition curve in the grade line. It is necessary to use a curve that lies 200 meters on the side of the vertex of the straight grade and 100 meters on the other. The station of the beginning of the curve is 200 meters side is 10 plus 000 and its elevation is 220. So we must determine the elevation at station 10 plus 040, and if the uphill edge of the underside of the bridge is at station 10 plus 220 and at elevation of 229.20, 206 meters. What is the vertical clearance under the bridge at this point? Letter C is determined as the stationing of the lowest point of the curve. First is we must get our elevation at station 1040 or 10 plus 040. Here's our given value or given figure. So we must get first our h by getting the formula or using the formula. 8 divided by 300 is equals to 2h divided by 200. Then we must get our h, which gives us h is equals to 2.67. By getting the our y1 is using the formula. Y1 is divided by 40 squared equals to 2.67. Our h divided by 200 squared. Our y1 is equals to 0.107. Sorry, di ko nalagay. And our y2 is equals to 1.71 given, or the substitute given all values. To get our elevation of station of 10 plus 040, so we will add or minus our 228 minus 0.03, our G1, 40 plus 0.107, our Y1. These are Y1, sorry. Then we have the elevation of station of 10 plus 040 is equals to 226.907 meters. Next is our clearance under the bridge. So let's get first our elevation of point of intersection is equal to 228 minus 200 times 0.03. Our G1 is equals to 222 meters. Next is our elevation of C. Top. Then we will use our add our 222 our PI plus 0.05 our G2 times 20. We will have 223 meters. Next is our elevation at D. Is equals to 223 our elevation C plus plus the value of 1.71. Then we will have 224.71. And our vertical clearance H is subtracted by 224.71 and by 229.206. Then we will have our vertical clearance H is equal to 4.496 meters. Last is by getting the stationing of the lowest point of the curve using this figure. We must first get our L1 and our S2. So L1 times G1 divided 2 is equals to 200 times 0.03 divided by 2. Then we will get our 3 meters is greater than 2.67. The lowest point of the curve is on the right side. So our S2 is equals to G2L2 squared divided by 2H. Given or substituting all the given values, then the old S2 is equals to 93.63 meters. Then the station of the lowest point of the curve is equals to 10 plus 300 minus 93.63 our S2, then we will have 10 plus 206.37. Next is by using English and symmetrical. A negative 3% grade meets a positive 5% grade near an underpass in order to maintain the minimum clearance allowed under the bridge and at the same time introduce a vertical transition curve in the grade line. It is necessary to use a curve that lies 656.168 feet on the one side of the vertex of the straight grade and 328.084 feet on the other. The station at the beginning of the curve is 656.168 feet. On the side is 328 plus 0.08.4 and its elevation is 748.031 feet. So we have to determine the elevation of station at 392 plus 39.63, and if the uphill edge of the underside of the bridge is at station 335 plus 30.18 and at elevation 351.988 feet, what is the vertical clearance under the bridge at this point? And lastly, determine the station of the lowest point of the curve. First, we must get elevation at station 329 plus 39.63. This is our given figure. We must first get our h. So by getting the formula or using the formula 26.2467 divided 984.252 is equals to 2h. divided by 656.168. Here's our H is equals to 8.748. So we'll get next our Y1. By using the formula, Y1 divided by 131.234 squared is equals to 8.748 divided by 656.168 squared. So we have Y1 is equals to 0.3349 and our Y2 is equals to 5.59. Sorry, here's the computation for it. So we have the elevation of station 329 plus 39.63 is equal to 2454.169 minus our G1 0.003 times 131.234 plus 0.349 our Y1. Then we will have 2450.58 feet or 580 feet, sorry. Next is the clearance under the bridge. So we must first get the elevation of the point of intersection. 748.031 is subtracted by 656.168.0.03 or times 0.03 is equals to 728.3545 feet. Next is to get the elevation of C is equal to 728.345 feet RPUI plus 0.05 RG2 times 65.616. So we will get our C is equal to 731.625. Next is we will get our elevation of D by adding our elevation of C plus 5.59 is equals to 737.215. In getting the vertical clearance H, we must subtract the 751.988 minus our elevation D 737.215. Then we will get our vertical clearance H is equal to 14.773 feet. Last is by getting the station of the lowest point of the curve. Here's our given figure. Then we must first get our L1. L1 times G1 divided by 2 is equals to 656.168 times 0.03 time divided by 2 is equals to 9.84 feet greater than 2.67. So the lowest point of the curve is on the right side, so we must get the S2 is equals to G2 L2 squared divided by 2H. Substituting all the values or the given values, then we will get S2 is equals to 50.392. And to get the station of the lowest point of curve, you must add first the 337 plus 92 plus 6.1 minus R S2 50.392. Then we will have 337 plus 42.259.